is calling me. It speaks both day and night. It's full of dark and light, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space, fields and forms, path and voids. It all seems with one voice. It's home. Boundaries set, foundations laid. Sound was heard, matter made. Solar systems from afar. Names and numbers for the stars, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. It's the Lord's.
Well, hello there, everybody, and welcome to SkyTour livestream. Tonight's going to be a fabulous night in the desert. I'm here, of course, with Daryl. Daryl, how's it going?
Mark, I'm well, thanks. How are you? Hello, everybody.
I'm doing just fine. Trying to get my camera up. I just had it up. It was working fine. Well, while we're waiting, this is a comet we're looking at right here. This is Comet Olbers. It's really low on the horizon. Look at the telescope's leaning. I am going to be able to show that to you as soon as it gets a little darker. It's going to get a lot better. Alright, so you can still see a glow from sunset right here. So we're going to wait a little bit and come back to it. We're not going anywhere, don't worry. But we are going to sit here and do our 1 second exposure shots. Alright, which will acquire it, and as it gets darker we'll be able to see it better. Meanwhile, I'm going to show you a little something which I think is kind of cool, and that is our telescope. This is the new system for Wickenburg, and I know, Daryl, you can't see it because it's going to be on the other setup here. So, all right, so there it is. That's an 11-inch telescope. Well, by the way, these are our t-shirts. On the front, you have the SkyTourLive.org, and on the back, it says The Universe Live in Real Time. These are available from us for $25. And here's a symbol of the telescope that you can see there. And this is the new system we'll be using. Okay, so we can actually move the telescope in any manner of directions. Okay, and if you'll see, the telescope is moving in the image, and it's also moving in this graphical portrayal. We can set the thing to go to the home position, which I'm doing now, and it's moving up. This is, again, an 11-inch telescope. That red thing on the back here, that's actually the autofocus system. This is the new mount. We're going to replace the mount for our current telescope out in Sonoran Desert with one of these. And it's going to rest higher on the mount so that we'll be able to capture objects that are lower to the horizon, even from Wickenburg. That's the plan. So this is called Green Swamp Server. It's actually quite nice, and it's going to serve as a system that's going to last for quite a while for us. As I move the telescope barrel away from us, you can actually see the focusing system right here. And it's quite nice, quite nice. This is an 11-inch telescope. The Sonoran telescope is a 10. And I want to say that this telescope system, as you see it here, plus additional hardware that we have, is courtesy of our patrons and the folks in the Patreon. We're not making any money on this. This is set up in our SkyTour headquarters location, which is inside of Marianne's house in Mesa, Arizona. And it's set up next to her gun safe. She got one here and one over here. You can't see it. So it's actually...
2 gun safes?
Oh, yeah. One's way bigger than the other, in fact.
Yeah, my kind of gal.
Fort Knox, yeah. So anyway, there you go. And
I just have one, but it's a great big one.
Oh, okay. All right, so we're going to set our park position here. And the telescope's going to park in a way that's going to allow it to stay out of dust and be down far enough, you know, and out of the way. You see the barrel here turning downward. There we are. Now we're parked. Oh, there's Marianne. Hello. And there's Stan. Stan is a Navajo Ranger, and Marianne, of course. He's at the house. It's like Grand Central at Marianne's all the time, so that's who you just saw. I thought that was funny. Very cool. And they're probably listening in the other room. So hello, Marianne, and hello, Stan.
Hi, Marianne. Hello, Stan.
Stan has a book out called The Paranormal Ranger. It's actually quite a cool book because he and John Dover have had some absolutely incredible experiences. And Stan put them in print in a book. So the book is available. He's published through HarperCollins, so I'm not sure where it is available. Stan, have Marianne say in the messages in the chat where it's available if you're listening. But there you go. That's pretty cool. And so there we are. So I'm going to take us back now. Now Olbers is starting to sport a tail. How about that?
Yeah.
Not bad. Not bad at all. That's pretty good. I'm still trying to get my camera to work. It was before. I don't know why it's not now. I can get my straightforward camera to work. This one. You know, I can get that to work. But I wanted to get the other one to work too. So we'll try it again. Alright, and this is, by the way, in just our 1 second, our 1 second shot here. I'd like to get us to be able to see this little more detailed. So I'm going to go back into our stack here and stack the 5 second shots and see what we can get. I'm going to come out of low light mode with the deep sky mode. Alright, let's do this.
Can you hear the fireworks going off in the background from here?
I did. I didn't know if that was from you or from me.
That's from me. Sorry, I have all the windows closed, but it's still
That's
here.
all right. It's okay. You got a bunch of yahoos everywhere. All right, so this
God
is
bless America.
yeah. All right, so we're gonna, as you can see, we got this rim around it like this because we're looking directly to the west where the sun has been setting. And let me move this down a little bit. Or we'll let this expose for a while, trying to see what it can get besides Starlink satellites. Yeah, I guess I gotta use this. There we go. Alright, I'm gonna change my size here since I've noticed it's now interfering. Alright. Okay.
Zoom, zoom.
Yeah, zoom, zoom, zoom. Very cool. Alright. I just lowered the volume of the music a little bit. Does Olbers have an anti-tail right now?
Not that I'm aware of.
Yeah, I see stars then. That's stars.
Not to say it couldn't.
Yeah. I was hoping we get to see Comet Olbers because this is actually very cool, and hopefully it'll get dark enough for us to look at Comet Olbers with a little more detail. Right now, that is not the comet we're looking at. That's the comet we're going to be seeing in just a little while, because we'll check that one out too. All right. So look at this. This is crazy. Wow. Man. What can I say? And there's the the label for Comet Olbers. Okay. This is only a 5-second shot, but it's still bright on the horizon, so it would actually be difficult to go any longer than this right now. We have to wait just a few more minutes for it to get a little darker. I see the tail going off this way, it looks like.
Yeah. Tail looks a little different than
Yeah.
Tsuchinshan does.
Yeah.
I'm going to say 2023 A3. That's easier for me.
Sure.
Tail looks a little fatter and
Yeah.
maybe longer if it shows better once it gets dark.
Yeah.
We're in a race with the comet setting, folks. It's only 20 degrees high now, and it's headed toward the west-northwest horizon as it sets.
Yeah. I want to say hello to Renee Cruz, who was the first one here. Hi, Renee. And
Izabela's here.
yeah, and Donald Kunzer, Asher Real. Hey, Asher, how you doing? Tim F is with us. Okay, Daisy and Zoe Amethyst. How are you guys? Sam S is with us. Nice to see you, Sam. And we have Stephen, Mr. Django, in Belgium. Nice to see you. Good morning to you. We have Cosmic Ray is with us. And we have Marianne Robb, who said they couldn't resist. Well, Marianne, what I want you to... Oh, here it comes. Okay, the book... She writes for Stan's book. The book will be available on October 1st, but you can pre-order on the HarperCollins website. It's the book called The Paranormal Ranger, written by Stanley Milford Jr. Stan's a dear friend of mine. He's a wonderful guy, and he's one of the Navajo Rangers. And he is... he's a very quiet guy. He doesn't jump out of his skin or anything to do anything crazy like the rest of us do, But, man, he's a good observer, and he has strange things happen to him. And, when we, he probably won't want to talk about them, but he talks about the, SWs, which we don't say the name out loud as best we can, especially on the air. But they are a phenomenon.
Rhymes with sidewalkers?
No.
Sidewalks?
No.
Am I even close?
No. Oh, well, kind of. Half the word, yeah. There's a TV show about it.
Yeah.
Anyway, so there we go. So the tail's starting to show nicely here. And I do want to also say hi to Fantasy, who just dropped in. Hey. Yeah, 107 where you are. That's nice. I like it hot, I can tell you that. Judy M, nice to see you as well, Judy. Izabela, thank you for coming. It's funny, I did a shot last night before clouds came in of the Blue Horsehead Nebula, one other area of it, to do a mosaic. And just as... Yes, Fantasy, that's correct. And just as I finished that one, it clouded up. The desert has some weird clouds, nice night now and then, and weird effects. This is, by the way, this vignetting is actually due to the way this is trying to flat field our screen when we have bright light on the horizon still. I could have turned it off, but that would have changed a lot of other things. The tail is going like this far as I can tell. How big is his tail, do you know?
Not offhand, no.
Okay.
Boy, Tsuchinshan,
Yeah, 2023 Atlas, yeah.
yeah, it's not much higher than Olbers is, and it's you sneak a little bit to the farther south along the western horizon, and actually they're not very far apart.
Okay.
Interesting.
I'm going to clear it and start over so we can see if the sky's going to be a little bit darker for us. All right, let's color correct first. And now let's do this. Okay. And now we'll move this up the curve. Okay, that's a little better. We're getting this color here from the deep colors of the sunset out there. And I'm going to put this over here. Drop a little noise out of the way. Oh, that's nice. I'm now going to get rid of color noise by clicking this. Watch the improvement. Bam. Look at that.
Can you center that up some?
It's actually... I'd have to center it up. I'd have to quit, go into 1 second, low light mode, and then come back.
Alright.
I don't think the tail's going very far this way. Let me see what I can do with this. Drop this way down. You can see the fuzz right there.
Yep.
Yeah, that's Comet Olbers, guys. That's one of 2 comets we're going to see tonight. Nice. We have 13 frames captured on this. This is only only a 5-second shot. What I'll do is I'll save it. We got 14. I'll get to the 15th. Okay, there we are. And I'm going to save it again. Save exactly as seen. Then we're going to clear the stack and we're going to try to do a 10-second shot. Not sure if that's going to work with the brightness of the night sky right now. But we will see. Oops. Didn't do 10 seconds. 10 seconds. There we are. Alright. There's our progress bar down there. On the right side down there.
Ronald's there.
Hey, Ronald, you missed it. Oh, okay. 10-second shot works. I previewed the telescope for Benson, the Benson STLS sight scope. I showed people the scope. I might be able to jump back into that for him. Alright, so let's see about moving up our curve. How well can we do this? Oh, a little better. You can see the dust tail right there. Nice. Comet Olbers on display. Oh, your story. Hey, sorry, I forgot to say hi to you. I saw you there. You had a question. I went to the South Pole on Google Earth, and when I looked at the ground level view, it looked like a different universe. Why is there so much more to see? It looks like it's painted. Not quite sure what you mean by that, but try to explain a little better, because... Hey, Michael Galea. I'm interested to find out what you mean by that. You went to ground level on Google Earth. That's pretty. Let's color correct again here. See if we can squeeze out that blue. Yeah, there we go.
Olbers is a little, how would I describe this? Fatter, more broad than
Yeah. It looks it.
2023 A3 is.
Its coma seems larger than 2023
Yeah.
A3, but then again, it's probably a larger, more massive nucleus, so there's a lot more outgassing occurring on it, I think.
Yeah.
Your story, try to... Okay, what he's saying, when I look up, I don't see the colors in the bands. What bands? What am I missing? It's on Google Earth Pro Beta. I don't understand. Well, see, Google Earth... I always caution people against trusting Google Earth for much of anything, because it gets a lot wrong. For instance, it's trying to show you an ocean floor on every single place you look. And there's no ocean floor that's really there except in a very small amount. We only have 16% of the ocean covered with data in reality. Your story, how do you send pics? Yeah. How can he send pics? Oh, I know how you can send pics. Send them, your story, you can send them to me. And let me give you my email address. All right, it is right there. Okay, that's my email. All right, my email is mufonanalyst@gmail.com. So you can send me images of the pics and I'll check it out. All right, I'm glad you took a screenshot. Thanks, man. I'd like to see it. I also have to show you guys something else that I caught in the AllSky Camera. Now, a number of you here tonight may have been in the Jimmy Church show audience yesterday. I was on Jimmy Church for 2 hours, and I wanted to show everybody this amazing sight that occurred I actually saw this unidentified aerial phenomena fly through just before going on the air with Jimmy. And I made a little video of it, and I want to show you that video at some point, figure out how to do that. It's downright odd. You know, when you see satellites go over, you see the satellites move through, and this was moving at a satellite speed. But this thing did an S-turn. It actually went, and I caught it. You see it. I'll show you. It goes down like this, then it switches and makes a different, it goes in a different direction. So it goes like this. And I thought if it was a rocket launch, it would be course correcting. But I've never seen rockets course correct like that. And it dimmed out as it crossed the Earth's terminator like a satellite does. So that was weird too. This is cool. And I'll show you. I gotta figure out how to show you.
Mothership.
Yeah, mothership. Well, I mean, it's definitely unknown aerial phenomena. Now, I'm going to clear this now so we can start anew and get better ones. So, the other thing that happened was, for the first time in the existence of this AllSky camera system, the AllSky camera, after I told Jimmy and Jimmy's audience what had happened, the AllSky camera ceased functioning. I can get into the Raspberry Pi just fine, but I can't get the graphics display to come up with it. I have no idea why. This never happened. So it's been running for like a year. You know, I had it running here, and then I run it out there, in and out of the heat. It's running in the heat. It's running in the cool. It's just fine. Why is it doing it? I don't know. What happened? I can't tell you. But sometimes things are strange, and this is an example of one of them.
It's a mothership, I'm telling you.
Yeah,
Didn't like you looking at it.
Well, I won't deny that's a problem. Ronald says Marianne can fix it. Actually, I talked to her about it. I don't know that she can, because I don't know why I can't connect to the IP address for the Raspberry Pi. I should be able to do that, and something changed. Alicia Vieras is with us. Hi, Alicia. How you doing? Yeah. Trisha Ferreira, nice to see you. Good. Yeah. This is the first comet we're looking at here. Oh, Jeremy B is with us too. Hey, Jeremy. Nice to see you. Oh, Jeremy, I think you were in Jimmy Church's audience yesterday, Jeremy, weren't you? Sorry, go ahead.
Oh, I was going to say, I see faintest wisp of a longer tail on that comet.
Yeah, let me see if I can. I'm going to push this. This is 12 shots. Let me give this a big push like this and see if we can see any more. Still bright out there near the horizon. It's the worst place to observe a comet from. The fact that we can see it like this is actually quite good. I'll do it this way, where we can actually do it in a metered amount. Okay, I see a tail. I see it extending to about here. Maybe a little further. Well, Jeremy, that's cool that you were on Jimmy Church's audience. I hope you enjoyed my appearance on the show. I've talked about in lectures that only 16% of the ocean is mapped. So when you see the ocean floor on Google Earth, you're looking at coarse data that has been interpolated. Unfortunately, what happens is people look at places like the Malibu Canyon, and they see this steep drop off, and it looks like there's like entry points, like you can go in. That's an error of the data. It's not an actual feature of the landform. It's because that part of the canyon doesn't have high resolution data, so it's interpolated. And they know the bottom and they know the top. All right, they don't know the slope. So from the bottom, okay, the next thing without knowing the slope right there is they just make it a straight cliff, and then you see the slope down below it, you know, the rest of it. So it looks like stretched data going downward because that's all they've got at that particular point. And Darlene here, is that what she says?
Yeah, Elisha.
Alicia, what'd she say? Darlene's
Well,
with us?
yes.
Hey, Darlene, what's up? Darlene wants to know what determines how long a comet tail is. Actually, it's a very good question, Darlene. When you look at a comet's tail, you'll notice that it sometimes looks blue, and it sometimes look dusty, and sometimes both. So what you're looking at is two different kinds of tails that comets have. The tail that's blue is always pointing directly away from the sun, because that is a chemically produced tail called an ion tail, and the chemicals, the elements that you know about elements, chemical elements, are caused to glow blue, and they stream away from the comet's head, the front of the comet. And because the sun is causing that, these things always point away from the sun directly, these particular tails, and they're called the ion tail. The one we're looking at right here is the tail that kind of has the color of the sun, and that's because it is reflected light off of dust that is left behind in the comet's orbit. If you ever saw Charlie Brown and the Peanuts cartoons, Pigpen, as he's walking around, is always leaving a dust with him. He's always dirty, and you see dust coming off every time he walks. It's hilarious. Well, that's what comets are. Comets are like Pigpen. As they move through space, they're just sending dust off of themselves, leaving a big mess behind them as they go. And it persists. And sometimes the Earth flies through those comet tails. And that's when we get a thing called a meteor shower. Those little tiny particles, small as a grain of sand or smaller, will actually burn up in the atmosphere, and you'll see them from literally 90 miles away. There's a lot of energy expended when these things burn up. And Darlene says hi. That's good. That's really good. And it was a year ago, just the other day, when Darlene and I posed for pictures in our booth, I think in Roswell. That was a lot of fun, you know. And her mom Alicia was there, and her dad Donovan, and that was actually pretty cool. Yeah. Let's see what we got here. Color correct. I think we're good. You can see where the telescope is leaning way over. We're going to end up getting affected by the wall sooner than later. But let me see if I can pick up a little more detail here. Okay. That's pretty good.
Playing with the comets here on my screen on the Sky Live. Whoops. What did I do? It looks like the comets are going to be going away very soon.
Okay. Look at this. If you look here, folks, if you look right here, just look here and notice that the tail seems to extend farther out to here. That's called averted vision. I think we're seeing that. Okay, I save that. I'm going to clear it, and I'm going to do this one more time. And actually, I'm going to do one more thing. I'm going to clear out of here and do what you suggested earlier because I think it makes sense right now. Because if the tail is now showing longer, we should be able to bring this in. So I'm going to move the comet over by going to the east a little bit. That actually moves the telescope a little higher in the sky.
All right, I misspoke. Olbers is actually climbing right now. I was hitting the wrong button.
All right, cool.
Olbers is slowly, day by day. It's I think it's getting a little more altitude.
All right, so when we look at this now, look for the tail going all the way out to at least here, okay? And what I'm going to do now that it's darker is I'm going to do a 15-second shot of the comet. All right, 15 seconds, and then we'll live stack it again. We're underway down here, as you can see. All right, so the live stack comes on board now, and we're gonna come out of low light mode. Now we're in deep sky mode, and let's see how this works. There we go. All right. Let me just back out a little bit. Okay, color correction applying. There we go. Take our black level and take it just to the left of the peak to maximize the amount of data we can capture. I see the comet going, the tail going all the way out to here, don't you?
Maybe about halfway up. That's what I see.
Okay. If you look here, you can see data out here.
Yeah. It's the tail is pointing up at about 10 o'clock from the nucleus, and I think I see tail along that line about halfway toward the top edge of the screen.
Yeah, I see tail all the way to about here.
I was thinking that earlier, but giving it the benefit of the doubt.
Sure.
The comet does appear much bigger coma, I guess, and the whole thing is fatter than Tsuchinshan is.
Yeah, so basically, let's do this. Okay. I'm trying to grab these. You can move these around. I did it the other day. Oh, it might not. Maybe I have to select them. Trying to get a measurement line here, that's all.
Huh.
Oh, maybe this is what I gotta do. Don't want to lock it, I want to adjust it. I should be able to move these now.
Thank you, Izabela.
So from there, I'm seeing tail going up at least almost 2,000 pixels, 1,900 pixels tall. Oh yes, thank you, Izabela. Okay. So let me move this off the comet and do it this way. Yeah, because I see it right about there. And let's see if we can push this a little, bring out more detail. That actually muddies it up, doesn't really help us too much.
Yeah.
All right. But I can see it though.
It is getting so low, you're probably getting some extinction from that.
I think I'm definitely hitting the building.
Yeah.
Well, look at though. See that? You can actually see this tail now, way up here. It's over 2,000 pixels on this scale. Definitely there.
Nice.
That's really nice.
Yep.
That's not. All right, so we got that. All right, that's cool.
You gonna look at Tsuchinshan?
I am.
Tsuchinshan.
Tsuchinshan.
Show up.
All right, so what we're gonna do is.
I'll just say Purple Mountain Observatory.
Oh, there you go. That's where it was.
That's supposedly what
Yeah.
Tsuchinshan means.
Yeah. So there's the nucleus. So the nucleus is outgassing. These can be these. They're called coma. The coma. It can be millions of miles in diameter. It's just massive comas around these. And then the dust tail behind it is just shedding. So as you can imagine, the comets are evaporating every single time they go around the sun. Accelerated evaporation occurs like rapidly when it's going around the sun. Now, sometimes when you make an image really small, you can see a detail. Now you can see that tail.
Yes, it does show up a little better.
Yeah. Yeah, and you can see the Starlink satellites that are just obliterating us. But that's fine. Okay, that was Comet Olbers. And what we're going to do now is I'll just do one more save.
You want Tsuchinshan's coordinates?
I do. Let me first get out of here and go back to our low light mode. Oh, that's pretty. That's a beautiful comet. All right, that photo will be available for you if you want it. Okay. There we go. Let me increase our size. Okay. And we're now going to go to Tsuchinshan. And I'm going to just get rid of this. Okay, what do we got?
Right ascension, 11 hours, 14 minutes, 35 arc seconds.
Done. And all right, 11, 14, 35. And now this guy. What do you got? 2?
Declination, +2, 36, 16.
36, 16. Okay. Let's do a go-to and see how well it works. It's not going to move that far. And we should see the second comet. There it is. Okay. Let's bring it up into our field a little more. I'll tell you, the invention of the go-to telescope was amazing. Hey there, Marcin Johansson. How are you? Okay, let's move westward, which means move the objects in the view toward the left. Okay. I know, long time no see, Marcin. Thank you for dropping by. Pleasure to have you with us. All right, so there's the comet now. And right now we're going to do a search here to find our guide stars.
Marcin, have you looked at the illustrations in that book? Those are so cool. Artist name is Steel Savage or Savage Steel, I forget one or the other. Has a very unique style.
Steely knives, and you still can't slew the beast.
Excuse me?
Stab it with our steely knives and still can't slow the beast?
Close. No cigar.
All right.
It was the artist's name, the guy who illustrated the mythology book he got that I told him about.
Wow, okay.
Steel Savage or Savage Steel, one or the other.
Okay.
Really cool illustrations.
That's neat. That's liking that. That's liking that. Okay. Alice Pooper, what's up? Nice to see you. Okay, we are still searching here, but I'm going to take advantage of that anyway, and I'm going to do a 15-second exposure just like the other. And we're in low light mode, so I'm going to get out of low light mode and get into deep sky mode as we start a stack. We'll see Comet Olbers right here. You can see that clearly now. Okay, now we're going to look at a smaller comet because they're not that far apart in distance. But this particular comet, for some reason, out by Mars or so. All right, there we go. You can see a vast difference between them.
Yeah. Comet Olbers is about 6 million miles closer to us than Comet Tsuchinshan here is. Cosmically speaking, I mean, that's not very much. 10 million kilometers, 6 million miles. So you can see that Olbers is apparently a much bigger comet.
Yeah.
Tail's longer and it's a bigger, fatter comet.
Yep. And this one is Comet C/2023 Tsuchinshan-Atlas, and it is a comet that's actually a little further away than Olbers, as Daryl just told you. Getting some red here again. Still getting rid of the night imagery here. The night colors. Sorry, sunset colors.
When we saw Olbers, it was Earth on average is 93 million miles from the sun. This time of year, it's actually about 91.5 million miles because we're closer to the sun in northern summer. Olbers was 106 million miles away, and Tsuchinshan would be about 112 million miles away. So roughly, comparable distance from the sun as we are.
Mm-hmm. I just added an illuminated keyboard to my system here so I could type even in the dark. I don't know why I didn't think of it before. I just bought another one too. It'll be here in it says it'll be here tomorrow, but it won't be. It'll be here Friday. But it helps so I can type things and not get them wrong. I want to also take a moment to tell you about our application. And the application that we have is a wonderful application that is for looking at every observation we've made in SkyTour Livestream since 2021. The application, of course, written by Izabela in Bulgaria, because she's crazy that way and amazing that way. She actually has it set up so that you can filter and look at, say, every photo of comets we've ever taken, every photo of Orion Nebula, every photo of a planetary nebula we've ever taken. And then, on your own, you could go and compare them to each other. And when she's done that, she discovered asteroids in here that we didn't know were there. And she also discovered in some cases, apparently stars that have disappeared. This is a interesting development because no one thinks or thought that stars would just disappear, but in fact they can. And Beatrice Villarreau is another person she's an astrophysicist, and she's doing a study on disappearing stars. So it's interesting. I know Beatrice, and it's a neat approach. And she was just supposed to deliver a talk at a conference, and for some reason, in that particular talk, they kind of shunted her aside, and it really irritates me that they did that to her, because she's got some research she's doing that is actually quite valuable. You know, I mean, you look at a scene like this now, say that star right there. What if that star disappeared 2 weeks? What would it mean? You know, or in a month? It might mean that there's an interstellar dust cloud that's blocking it temporarily. Well, no one's tracking that stuff. There's some studies, but not a lot. So that means that we would have to get on the ball to do that. And thanks to Izabela and the applications she's developed for us, that's something that we can do. And I actually think that's really cool.
It's the star eaters.
Star eaters, yeah.
They're probably hanging out with the mothership.
Daryl. Yeah. We'll let that come in a little longer. And I'm going to try something really quick here. Okay, that's just this guy. I'm trying to get to a window capture. I'm going to add one and make it a new one, and I will call it STLS Companion. It's actually the STLS Stargazer Companion. And let me see if I can grab this for you. There it is. Okay. Alright, so this, and meanwhile we have this going on in the background here, so it's okay. So here is an example of the STLS Stargazer Companion. It is got many different features. It has a table of every single observation, complete with the exposure, how long we've exposed it, the sensitivity, how big the stack is, and which telescope we use. Now that we're getting more than one, we need to capture that as well. And right now we have 1,741 observations in there. That's almost 2,000 observations. That's pretty good. Now, this is the table version. This is the gallery. I did this the other night, if you recall. And this is the M16, the Eagle Nebula. And if you click on it, you can jump in and check it out. Isn't that cool? These are the pillars of creation. All right. So this is all available to you, and you can come down here and see details along with some notes that might be taken. What camera we used, again, all this detail. And most importantly, you can go look at the live stream that it was in. You can look at the object folder where it's stored on the server. You can look at the session for all the observations for that night. You can get the image file, and you can get the raw data file to do your own analysis if you wish. Okay. Now, let's suppose you want to do something else. Let's suppose you want to look for different types of objects. Well, here's different object types, right? So, for instance, this here, EN, what's that? You click on it. Emission nebula. Tells you all about emission nebula. And now we can say, show me all the emission nebulae we've taken pictures of. And here they are. And you can scroll for hours and hours looking at all the emission nebulae that we photographed. Take them down, look at them. It's really impressive. And then if you want to do it by the month, well, look, you can go look at, this is July right now, okay? You can look at the month. Okay, back in June, we looked at all these things. And if you click on them, here's C2023 Tsuchinshan, okay? And it was down here that we looked at it. We click on this, and there it is. Ta-da! Okay, and once again, you can come in and jump in and check it out. So you can see there's a variety of ways you can maneuver around and see what's going on. We're on the verge of deploying this to everybody, and I'm waiting to hear back from the company on whose platform we'll be deploying from. And Izabela is helping with that, of course, and she's had a tremendous number of ideas that are really good. We also have a histogram where you can look at all the different objects we photographed and see the frequency of the times we did it. North American Nebula takes the cake. Okay, we've actually done that quite a lot. And Orion and Running Man Nebula as well. Actually, no, it doesn't. Orion Nebula takes the cake right there. So that's pretty cool. You can get information about the app, right? And see what it is, what it does. And then you have the app gallery, which is just all the stuff that we may have done. There's nothing in there right now. But there you go. That is the STLS Stargazer Companion. And I'm just barely scratching the surface because, for instance, you could look for Orion Nebula. Let's say Orion. As you speak it, it's coming up. If I say Orion Nebula, well, that changes the output, see? Now you can see every single time we took pictures of the Orion Nebula, all right, and in the region of the Orion Nebula, all right? That's one way to do this. You can also get out of this and go into these filters. And now you can look up the time, an object name, other designations for the object, what type of object it is, what constellation it's in. You want to look for, okay, let's do this. Let's look in Monoceros. All right, and look at all things we took pictures of in Monoceros. Well, there we go. Here it is. And it's the Rosette. It's the Seagull Nebula, Dryer's Nebula, Christmas Tree and Cone, right? And you can see that we've taken pictures of nearly every object in here. And we also have Hubble's Variable Nebula. We have the Angel Nebula. It's really, really amazing what you can do here. So I think then you can just click on that and get back to the regular thing. So basically, you could search on how we did for gain, what right ascension and declination location you were in, and then there's a lot of things you can do. A lot of search capability. So I hope that you guys enjoy this, and if you do, please show Izabela some love, because she poured her heart and soul into this, and what she's done for us is an immeasurable service. I'd have to say that she's probably the most essential element of SkyTour livestream when you look at what she does for us. I'm just a big mouth who sits in front of the telescope. She's the one who's doing a lot of the hard work in the background. So show her some love. And, please enjoy the app if you get a chance to download it, or if you do download it. Now, as far as cost, okay, we would like to give it away, and we're going to see if we can do that. But it depends on what it's going to cost us per month. We're not looking to make a killing on this. We're just looking to make back what we put into it. We are a non-profit corporation, so we want to try and balance everything we do with some type of value. Okay. All right. So I'm going to save this under. This will be Comet Tsuchinshan-Atlas. I'm going to back here and get rid of the slash because I think it's not going to like that. Alright, there we are. Nope, that one. Then this one. Okay. So that's pretty
Mark,
good.
Would you excuse me a moment, please?
Sure.
Be right back.
All right. So, let me know what you think of that short little exposure to the app, that little teaser. We have browser versions. We're going to have a PC version, which is effectively the browser version. It'll work on the Mac in the Mac browser. It'll work in a PC browser. And it'll be available for Android and Apple. So it's on the phone, actually, it's really pretty. On the iPad, it's pretty. On the PC, it's pretty. It actually has a good appeal on every platform, which I really like. You know. Okay, we're going to clear this now and then start again. Meanwhile, I'm going to look, while we're doing that, I'm going to look here. Back away. And we're now at the point where I can come over to the blue horse head because we're not that far away. And the blue horse head is actually a beautiful reflection nebula that glows blue. And I recorded and captured 2 segments of it. And I'm going to record and capture another segment of it tonight. But we also have things like the Dark Horse Nebula that we can look at. I think we can see that too. That's a dark nebula. Its elevation is 39 degrees. Might be just visible to us. Yep. Jessica, thank you. She says, nice, Mark. Well, thank you so much for that. I'm glad that you guys got to see it anyway. Okay. AppSheets is free, Cosmic Ray, for up to 10 people. And it's not crippled in any way. So what we're doing is we've made this app. She's made the app, and I've been helping her, and Daryl's been helping her. We've been testing it and so forth. And it's going to be, like I said, it's going to be available. And when we start to deploy it, then we actually incur real cost. Okay, let's do this. And save exactly as seen. Nice. Okay. Marson, thank you. Happy July 4th to you too. Thank you so much. That's very kind.
Happy Independence Day.
Yeah. Okay. I was thinking, now that we did this, I'm thinking I want to check out the Dark Horse Nebula, don't you? Not the blue horsehead, but the Dark Horse. It might be available to us now. Summers are coming. Summer sky is here, obviously, but summer's here. But the objects in the night sky are lagging behind a little bit. We have to wait for them to get here.
The Dark Horse, the one.
This one.
Yep.
So let's see where that is and how much elevation it has. It's a little into the east, and that's actually not bad. And you can see the telescope moving into the east up there. East is on this side of the building. West is on that side. North is to the back, and out toward you is Oh, it looks like we can make it. Out toward you is south. All right, there we go. Okay, we may have to just correct for our position here. And I'm going to zoom in. We may have to do a star focus routine. Yeah, we do. Okay. We're going to focus. Guinness Stash. Hey, man, he lives in Mass. I have like 10K setups I have built over the last few years. I have nothing to look at. It sucks. Actually, if you have that kind of setups, you know what? You probably know about the different filters you can use, right? I mean, you can use a UHCS filter. Radian makes some nice filters. And you can see through the light pollution using, if you get to it, narrowband. You might need a filter wheel. So that's pretty cool. Yeah, our setup out in the desert, well, and we had to build a building too, so it's a little more than that. But still, it's okay. You know, we actually, my next building that we're designed here is, we're using linear actuators. We're just going to pop the top right off the building, the whole building, and like opening the lid of a box, and it's going to set down out of the way, leaving the telescope fully exposed to all the horizons, even though, you know, as astronomers, we don't usually ever look at the horizon. But still, it's going to give us access to things like Omega Centauri for the first time. Even though it may not be that good, it's going to look, you know, interesting to everybody watching, because after all, I am doing, you know, public education with all of this. Right now I'm focusing the telescope, so as you can see, there's a line here of increasingly focused shots. The stars are getting smaller, and it's going in increments. Up here you can see that it's on step 6 of 12. It's halfway through the focusing run. And when it gets down to the bottom of this logical parabola it's building is the best focal point where the stars are the smallest diameter. And when it starts coming up on the other side, like it is now, it's making this parabola here, and you're going to see a line probably right there. See, there it is. And that's the line of best focus. And it doesn't necessarily line up with the exact location that it put a focus set. It's interpolated. It interprets the best location. All right. And now, as you can see, it's automatically going to the point of best focus because it found the best focus position. It stops, and now the stars are going to be nice, beautiful pinpoints. Okay. Automatically focusing, that's a feature that the author put into this program because I talked to him about it and said I'd love to see it do an autofocus routine. And so Robin, the author, he put a routine in to do the focus run and then automatically go to best focus. Okay, now that we've done that, we're going to take a picture, an image here, and I'm going to move us over to the west by 1 Jagaruni here. And we're going to take a picture that's 35 seconds. And I'm waiting. There we go. We're guiding now. So we're going to come out of low light mode and go into a stack mode. You'll see the last photo we took, which is of Tsuchinshan-Atlas, and it's up on the server now, so we can clear this. And we are at 200 gain. We might want to go a little higher on the gain. We're going to see. I'm not sure if we're looking directly at this. This is where the telescope thinks it is, but there might be a little bit of a difference. But we'll see in just a moment. Actually, we're in about 1 second.
And what Stellarium calls the dark horse is actually just one tiny small part of the entire nebula.
Yeah. Okay.
That's the one where the pipe nebula makes the horse's back leg.
Yeah.
And runs quite a ways up farther north from there.
Yep.
North and northwest.
Here's our spider web out there. It gauges wind for us, although it doesn't know it's doing that. And we have a full width half maximum filter, which says if the stars are of around oh, look, there it is right there. Can't miss it. That's beautiful.
Oh.
So that was actually quite an accurate go-to.
That's actually more than I thought it would. The part sticking out on the right, kind of a curve with the end pointing down, that's the horse's front leg, and that's his hoof on the right. That's his neck sticking up the top left, and his head is just out of the field of view.
Yeah. Yeah, we're in the summer Milky Way here, guys. So let's, this is actually, it was a good get. So what I'm going to do now is I'm going to move this up the curve. The red, green, and blue curves are here, and what happens is this white curve is the average of them. So if we color correct, all our curves line up perfectly underneath each other, and we get a more natural color of the what's there. And now this here is the mid-range, and if we move it right up close, you're going to see lots of noise. Okay, but it helps you see what's really there in the background to the level that it can yet. And so if we move it out, it will reduce the noise, soften the image a little bit in terms of the noise, and allow us to examine our data on the fly here like this. So I'm going to bring this up right to just before the peak, and this is about the best place to be. Yeah, there it is. That's pretty. You know what I'm going to do, though? I'm going to get out of this and go back to the 1 second for a minute. I'll tell you why. I want to move it to the right and capture more that's on the left. All right. So I'm going to move this star about there. So to do that, we're going to go to the east. Okay. I guess I should jog up a bit too to capture a little of the horse's head. I'll just do a little. Okay. All right. Now we'll acquire over here. We're searching. It takes about 11 to 14 seconds to acquire a guide star. And based on what I'm looking at, I think I'm going to go 40 seconds. And I'm actually thinking maybe I should go to 250 on the gain. That'll add a little more noise, but it will allow us to see much better. All right.
You're a madman. I
am. Okay, so here's our stack from what we just took. All right. So we're going to see 5 seconds more of data and 50 points more of gain. All right, we're going to clear this though. It may look initially like there's a little more noise, but we take photos and we're making an image sandwich. So we take one image, take a second image, align it with the first, and put it on top. And we just do this sandwich. And this becomes our whole stack. right? And that stack is extremely valuable because the more that we stack, the less noise actually interferes with what we're taking images of. Okay, so give you an example. If we zoom in on this image right here, right now, you can't really tell what's going on in here. This is all noisy. Look at all that noise. And every time we take another picture, let's see if this will work. If we get a second one now, watch how the noise changes now. See that? So now the noise is leveling out, and some of the stars actually came in a little clearer. All right, so we'll actually color correct. And now I'll move this down. That's beautiful. Now we can actually see a little more up here. There's more here. So what is this dust? This is the dark dust that is all throughout the universe. This is the dark dust that's all throughout the galaxy, in the arms of the galaxy. And it comes from the outer atmospheres of aging stars. It comes from supernovae. It's really interesting how this works. You know?
Looks more like a reindeer to me.
I guess so.
Like the horse has horns.
Yeah.
That looks nice.
And over here, we could actually be seeing the spider doing something in the web right here. As Ray says, the spider is there to prevent the scope from going to Cygnus. Oh yeah? I got news for you, pal. We probably won't go yet, because Cygnus is a little bit too far into the northeast and low, and we may not be able to get there. Alright, this is the Dark Horse Nebula. We got 4 shots here. I'm going to come up just to the left of the peak. Okay, and now I'm going to pull this way down here. Jesus. Nice. Okay, I got it. Okay.
Marson, the entirety of the Dark Horse is very large. I did a quick look and didn't see anything on how far away it is. You're looking roughly in the direction of the center of the galaxy, a little above it actually. That's quite an extended object. I dare say it's, there's closer parts and farther parts.
I moved
I'm going to
everything.
post a link to an image of the entirety of the horse.
Okay.
Right there, you can see if you can see what we see here, and then you can see the Pipe Nebula making its back leg, which is just out of frame on your image.
Yeah.
It's so big you can't catch it all.
Yeah. And we got a 1.5 degree by 1 degree field of view. Let me just make sure our focus looks good. Yeah, we're good. All right. So the more images we stack, the cleaner this will look. And Izabela won't get mad at me because she wants to have as noise-free data as possible. Obviously, I'm kidding around, but in the past, I taught Izabela lots about doing image processing. And in Photoshop, I've written actions that allow shortcuts to be used to get to certain places in the processing pipeline, as we call it. All right, I'm going to move this just to the left to kind of dig into some more data. Yeah, see, it's actually looking pretty good now. Do a little more. This glow right here is amplifier glow that you're seeing right there. Wow, I am impressed with this. This looks really nice. I'm glad we got a chance to look at this tonight.
You can see the darker wisps there in the upper part.
Yeah.
I guess the horse's neck and head, that would be.
Yep.
Some very dark strands of dark nebulosity.
Up in here.
Yes.
Yeah. Now, one thing you notice when we zoom in. Okay, first of all, we're starting to look a little toward the center of our galaxy. Not directly there yet, but every tiny little dot you see, this is a star that may potentially have planets. So we could, in part, be looking at other civilizations and not even know it. Let me do another little color correction here.
Oh.
There we go.
The actual center of the galaxy is a little out of the field of view to the lower left.
Yeah, it's down there, yeah. Beautiful, look at that. This is nice. So this is the first time we captured the dark horse with this camera. And I'm actually quite impressed. It's just amazing. Now, is this dark nebula? See, dark nebula is like a real turn on for astronomers. Why? Because it's in the dark. No, because it's actually the place from which life springs. It's in those dark clouds where concentrations of dust self-collapse into gravitationally bound clouds of dust, and they get smaller and smaller. And there's also gas in there. Hydrogen, the most plentiful element in the whole universe, is in the middle of all this, or in there as well, mixed throughout. So as it collapses, it gets warmer and hotter, and the gas collapses and gets warmer and hotter. And when it gets very, very hot, upwards of 10 to 15 million Celsius, the hydrogen can begin to fuse, and that becomes a star. Now that protostar that was in the center that maybe wasn't quite fusing yet has already got an accretion disk, a disk around it, in all likelihood, that has clumping going on, and those clumps become planets. And this is they all form kind of at the same time, which is really interesting how this works. So when we look here at a dark horse nebula, we're seeing the crucible of life, because this is where it's all happening, is in those dark clouds. Not in the bright red stellar nurseries. They're filled with deadly radiation. It's in the dark clouds that are protected from that stellar radiation where this occurs. The first step is a stellar nursery with the bright red clouds, or bright red gas that's glowing. And then as time goes on, those stars disperse and they change, they evolve, the temperatures cool off, and that leaves behind a fertile location for planetary and other star formation. Hey, Waldo. Waldo's hiding. Marston, thank you for coming. And thank you for the good cheer on the 4th of July, Independence Day. So thank you, my friend, for the donation. That is humbling. Thank you so much for spending time with us. Come back anytime. You're always welcome here. Okay, we've captured 15 stacked frames of this. And let's see if we can zoom into some of the features that you were talking about, Daryl. Whoa, that was a loud one.
Yeah, it was.
That one exploded on your roof.
No, that sounded like that was about a half a block away.
Yeah.
I used to have the best Independence Day noisemaker, and it was pretty safe, depending on how I used it.
Oh, the cannon?
It was a gas-fired potato cannon.
Oh,
yes.
yeah, I got one here in my right. I got one right behind me.
And mine was oxygen and MAP gas powered.
Oh, yeah, okay.
It sounded more, instead of that bloosh sound that usual potato cannons make, this thing sounded like a stick of dynamite going off. And the neighbor across the street and he had a potato cannon too. We would shoot wet Nerf balls at each other across the street. And they make a very satisfying slap when they hit the house.
That's funny.
So you get tons of noise, but no sparks, no.
Oh, yeah. Well, no, out of the mouth of that thing, there's a 3-foot flame that comes out of the muzzle.
Well.
Yeah.
But no sparks, though, I mean, it's...
Yeah.
Mine, again, is gas-fired, and it burned all the gas in pretty short order.
Well, as many of you know, my youngest son works at the largest TV station in the state, and he's a big-time cameraman there, traveling around the state and around the country, actually. He was in Phoenix, Arizona for a sporting event, and then in Houston. Well, he loves to, experiment with stuff. So when he found out I had a potato cannon, he said, "Can we do some high-speed photography, Dad?" Well, yeah, of course, I'm in. So we set up like 2-liter bottles of soda at the end of our driveway against a concrete wall, and we, stuck a spud down the throat of this cannon, mounted the cannon up, and I let him set it off, and we recorded the impacts in slow motion. And it's just like, and the barrel, the bottle's doing this. It's rippling under the withering fire of a high-speed potato, And then we sit up over a lake, looking out over a lake, and the lake's across the street and down the road a little, but you can see it from the front of the house, from our front porch. So the geese that are in that lake are poisoning the water. So, Mark D'Antonio, he decides he's going to take the geese out. Not really, but he's going to get them to leave the lake. So I calculate an angle that I think would be best. It's a little less than 45 degrees from where I'm standing, because I'm higher up the hill, so I can get distance by keeping a slightly lower angle. I think I ended up with like a 30-degree angle, and I shot from the front porch, and it went out over the phone wires, straight out into the lake, or hitting the center of the lake, and I saw the splash, from a long distance away. And now that we had the distance with our little mortar, we were going to go after the geese to try and get them to fly off the water, because they poison the water, and because people used to swim in that lake, and now they can't because of geese poisoning the lake water. So I ended up shooting from the front porch spuds into the lake, and you know what? All of a sudden you hear, and the geese take off and start flying around, and they disappear, and they go down the hill to the next lake, and they leave my lake alone. That's just displacing pests. That's all it's doing. No geese were injured in this process whatsoever.
There's a lake at one of the big parks here in town.
Yeah.
Prospect Lake it's called, and the darn geese have taken that lake over. As you said, people used to swim in this lake, and you can't anymore.
Yeah.
Plus, they're just mean, nasty critters.
Yeah. My sister on her farm, she didn't have a attack dog. She had attack geese.
Yeah.
And you go up the driveway, and this goose comes at you with his wings out, and it's biting you, you know. And if you were like a customer of the farm, that's spooky, and you go, it's biting me, and you'll scream. But they don't really hurt, you know. It's like going like this on your arm, you know. It's not like it's really gonna hurt you. They try. They don't have teeth. They got those little serrations. They have those little tiny. It feels like Velcro when it's rubbing on your skin. You know, the sharp part of the Velcro. And that's it. Thank you, Waldo. Eliza Raquel's with us. How are you? Yeah, well, yeah, the geese, you know, I have another story for you. Hunter, my youngest again, and I were up at the sister's farm, and they had a bucket of goose eggs, and they were pretty rank and smelled pretty bad. And my sister said, yeah, we got to destroy them because they're filling with gas. And if one goes, they're all just going to explode. Okay? So we took this little 5-gallon pail out into the parking lot, and we threw them into the woods. It was like throwing grenades. It was great. Because it would hit in the woods, and it would go poof. And you'd see this big thing. Poof. And there were about 20 eggs in there. And it was kind of funny because at one point, he reaches into the bucket, jostles one too much, and it goes poof up into his face. He got some in his mouth. It was like, bleh. Of course, I'm his dad, so naturally I was concerned for him and laughed my butt off. And it didn't actually explode all of them because the explosion was somewhat directed. So we had several left, and we heaved them into the woods. It was like poof, poof, poof. Really cool. Right, 25 stack now. Look at how much better this is looking.
You want a good alarm system for your place? Get guinea fowl.
Oh, yeah, guinea fowl.
I gather those things, they raise a ruckus whenever somebody shows up who shouldn't be there.
Yeah, but thieves aren't afraid of guinea fowl. They're afraid of, like, Dobermans and Rottweilers and pit bulls and, you know... Well, and cattle dogs, as it turns out. You know, my little cattle dog, boy, she can be a little mean one. Look at this really beautiful density here in this particular cloud. This is gorgeous, Daryl.
Yeah.
It's really turning out well. I'm gonna bring back our left side here. Okay, I'm gonna redock this to our bottom here. All right, this is beautiful. You can see now by going to 25, actually 27 frames now. Look what's happening. There's a lot of details visible in here that were not visible before, right? And that's what the target goal is to get the most detail out of this we can. So dark nebulae are one of those things where you've got to stack a lot of images. Because by making that image sandwich, the dark nebulae are automatically going to be covered by noise initially. And as you take more and more pictures, the dark nebulae rise to the top in terms of their data, and the noise is subdued. So that's why we can start seeing details in here. Let's go into the histogram. Let's see if we can pull out some detail here. Let's go halfway to here. Look at that.
Mark, Izabela is saying she's not seeing all the images. I'm not sure. Maybe just because you're not done taking images of the dark horse yet that it's not shown up on the server.
I think I probably have to actually save one before we do.
Yeah.
I didn't save any yet, these, Izabela. I'll do it now. Alright. The other one should be there, though. Hey, Lubo. Lubo is in China, and it's raining there. Rainy season for another 2 months. Sorry to hear that, man. What? Holy cow, I just realized.
Mm-hmm.
Yeah, I'm not applying any flat frames. That's crazy. We're gonna fix that. And I have the dark frame, but I'm not applying any flats. That explains why it's a little lighter in here. Okay, we'll fix all that. Let me just see if I can... That's there. Interesting that let me move this out of the way so you can still see it. I'll move it. Let's go. Come on. Oh, maybe this way. Okay, well, we can do a synthetic flat. That's fine for this image. But I'm interested why this didn't do what I expected. I may have removed it just to take images the other night. Okay, that's probably what happened. Let's do this. Oh.
The image center looks almost a little washed out. Could that be from the lack of the flat frame?
Absolutely is because of that. Yeah.
Yeah. I've noticed it seemed like it's been getting worse over time.
Yeah. It's okay. We can fix that. All right. Here's what I'm gonna do. I'm gonna come out of here for now. I will save this. Save it exactly as seen. That's 31 frames. That's pretty good. All right. And now we'll come out of this. And let's go and pull in a flat frame. I'm trying to remember which flat frame. Oh, I remember which flat frame I had. I got a photograph I took just for that reason. Because I did do exactly that. I did turn it and get rid of it for a minute. Alright, let's find that. There it is. Oh. Well, that's the dark. Where's the flat? Okay. Alright. Let me come out of here for now. Alright, let's go back here. And let's go see if we can capture... I don't know if we can capture this yet. Maybe we'll do the Trifid Nebula, I think. Trifid is just stunning. Alright, we'll center up on this. Yeah, let's see its altitude. At that location, it might be okay. We're going to try it. first things first, I gotta go back and set us to 1 second here. Do our low light imagery. Let's see what we got. There it is. Look at that. Beautiful. Okay. This is going to make a real pretty shot, I'm pretty sure. So let's drop the Trifid down. I'm going to also try it with one of my flat frames to help get rid of that change of color in the center like that. That brighter imagery in the center is not good. Having it brighter. Okay. So I'm going to move this over. My dark frame I have. That one is that guy. Yeah, that's good. Oh wait, where's the dark frame? Under desktop structure captures. Okay. Let's go look for the flats. Actually, you know what I can do before I do that? I can start taking this picture. I think that'll probably be the best thing to do.
Indeed.
Yeah. So what I'll do is come up here and set this to be a 30-second shot. All right. And then we'll start this underway. We are guiding. Come out of low light mode, go into our stack. You'll see the dark horse for a moment. And that's going to be up. Oh, geez, that's beautiful. And that'll be up on the server. And now we'll clear the stack. And now, while that's taking a picture, I'm going to go bring up the flat. I may have to restart once we do this, but that's okay. Alright, so let's see, we have sharp cap captures. This is, oh, look at that, that's stunning. Gosh. Those are the darks. Okay, but I can actually look for flats. Alright, one of these will be the flat frame that I remember. Well, we can try.
It's working well. You can see blue all the way around the red part of the nebula now.
Yeah, it's beautiful. Okay, let's see. Master flat. Oh, does not match. Okay, that was from the previous camera. Okay. It's actually good to know. I gotta be after November. Well, let's look with this for a bit too. Let's color correct this.
It's pretty.
Yeah. Notice the reds that show up there?
Yeah.
Those reds are actually due to the nebulae all around it. That's to say, nebulae in addition to this green, this blue and red. So now you see there's a lot of diffuse red nebulae around us right here. So if we pull this down, it allows us to see deeper into the nebula a little bit. That's pretty. What are you, sanding?
Excuse me?
Sounds like you're sanding something.
No.
Uh-huh.
Scratching my back.
Okay, so now... Well, that's nice. Let's take this back just a little bit. It's a little past our curve peak, so I want it to be a little to the left.
I wonder if the diffuse red nebulosity you mentioned,
It says here.
particularly that below the Trifid, on the left and the right, if that runs all the way down to the lagoon. Lagoon's not that far out of field
No,
below.
it's down here. Actually, it does run down there.
Yeah.
And then on over to the Chinese Dragon, to the left of it, to the
Yeah.
east. Okay, and it's having trouble aligning. And why is that? Interesting that it's doing that. We only got one frame here, so let's. It's actually kind of bright too. Let me go to 25 seconds. We'll do 25 seconds. It's doing milliseconds. I said 25 seconds. Yeah. Okay, clear. Clear. Tum, tum. Okay. I'm gonna find that. I know I took a picture of the flats. That's pretty. Let's see if it can stack. Let's see if it gets a second one. Oh, no, it's not. Alright, and why is that? Why is that? I've noticed this does this weird stuff sometimes. I'm not sure why it does it.
I see it says one stacked, one ignored.
And it's going to have two ignored in just a second.
Oh, two ignored.
Yeah. Okay.
What if it was something happened when you were fooling with the flat frames?
No, I haven't done anything with flat frames. I haven't added them back. However, I can try shifting the image over, and that might change things. I had that problem the other night when I was just doing some pictures for myself, and it was that very problem. Alright, so let's go back into the live stack and clear it. there's so many stars, it also gets lost, you know. And that's problematic too. This one might be a messy one if it comes in at all. Yeah, because we're actually interesting. Let me Trifid Nebula is so named because it has 3 distinct apparent lobes. They're not really lobes. They're actually just, yeah, see, it's got some vertical exaggeration there. That's because we weren't guiding properly at that point. So I gotta clear that again, start again. It's weird how the Trifid Nebula is like one of the only nebulas that does this to me. I don't understand it. See, we're guiding now. See those beautiful lobes? That's just beautiful. This one might work. I don't know why it's not doing it. Not sure why. Let's try a 20-second shot. This might be part of the problem too. Not sure why. Yeah, couldn't do 20 seconds either. I do not know what's going on. Oh, it's not doing 20 seconds either. It might be because we haven't been able to I should maybe have to do critical focus again. Let's find out. Waiting. Okay. Not sure what's going on there. Alright, we're gonna come out of this. Go back to a low light mode. Let's try going down and seeing if we can get to the lagoon right here. It's not far away actually, so if we can see the Trifid, we can see the lagoon. The lagoon is actually far and away the most beautiful nebula, one of the most beautiful nebulae in the summer sky. And there's the lagoon. Let's now we're gonna go north a little bit. The lagoon is powered by one of the hottest stars in the universe, effectively. Right here, right in there. Okay, that location inside the nebula is a location of something known as the hourglass. It's actually an O-type star, a very, very hot star, and it is ionizing gas for light years around it.
I was about to say that's called the hourglass, right?
Yeah.
Yep.
And if I move over to here, this will be good. And if I move a little to the right, it starts getting us closer to what's called the Chinese Dragon Nebula. Okay. Let's make sure that... Now we have less stars here. I don't think we'll have a problem. This is good music too for this. The universe is my cathedral. Okay. Let's do a 25-second shot for this. Okay, we're underway. Let's come out of low light mode. And check this out. Alright, this is one beautiful nebula coming up.
You mentioned the other day when you brought this camera online, was that after last summer?
Yeah, it was November when I brought this camera online.
Okay, so like the Trifid before and now the Lagoon, it's going to be our first view with this camera.
Yeah.
Wow.
Yeah.
That's really something.
There's the first view with this camera. Holy cow, look at that. Looks like a devil angel. Let's see if we get a second one.
We process that. Keep the red.
Shit. It's rejecting that. Why? What is going on? I don't know why it keeps rejecting these. Yeah, I mean, this is... I mean, it still is a pretty shot. Without a doubt.
Especially for being one image or one exposure.
Yeah, you can see some beautiful stuff in there. What is happening in there that's causing this? I don't get it. Very nice. And that actually softens a little bit of the noise, but I want to pull it up to near the curve here. Comment and see. Okay, I'm guessing that there might be something in here that I have to pay attention. No, you know what, Lewis tosses too many stars. No, it's not the problem. I actually don't know the problem. What I'd like to do, and this is just stunning. Again, this is the first time I've done this with this camera. It's really pretty. Holy cow. This is actually one of the more sensitive cameras they make. Why? I shouldn't have to... Shouldn't have to do this. Align using... Looks like it's working, you know, in terms of it's guiding properly. Okay, you know what I'm gonna do? I'm gonna do something crazy. I'm gonna go to the full width half maximum filter and I'm gonna turn it off. Let's see if that makes a difference. Nope. So it's saying it can't align. So why can't it align? Let me see if we tell it to align using only 10 stars. Let's see if that works.
Looks like it locked.
Like it locked?
Well, it looks like it found its place. Your telescope readout.
Oh yeah. Yeah, but it keeps rejecting these. Well, you know, I'm going to save this anyway as one image and then save it exactly as seen. I know it's only one, but I'm going to figure that out. And
I bet you mashed the wrong button.
not a whole lot of, well, there's plenty of buttons to mash, but I didn't hit anything in particular. Usually the Lagoon just is easy. Let me try 10-second shot just to see if it has anything to do with it. Now let's go back in. Yeah, of course. Clear that. Clear that. Now we'll get it coming in. It'll look relatively similar. Oh, it didn't work. Okay. Okay.
That's pretty cool looking right there.
Yeah. Let's do this. Alright, now see, it's stacking. It's doing it right. So why is it taking that sweet old time? Alright, let's go over here and pull this guy in. See, we can achieve the same thing. Alright, well, we're stacking normally now. I don't understand why it was doing that before. I'll look into it. Wow, this is pretty. And again, it's only a 10-second shot, but let's zoom in to right here. Look at that interesting dark nebula there. So the hot source in this nebula is right in here. There's an O star in there. O's are the hottest and the bluest. And it is ionizing all the hydrogen for light years around, causing it to glow red. But way out here, where it doesn't reach, there's dark nebula out here. And this dark nebula is, like I said, these are the places where life may form. And it could be by the very fact that this nebula is here and there's high pressure coming from the stars in here, pushing outward, that maybe what they're going to do is generate some level of pressure into the outer interstellar medium, or shock waves, that will then push dust in just the right amount to start a collapse and start the process. That's nice. Let's color correct that again. Here we go. Not bad, huh?
Oh, that's great.
Not bad for 10 seconds.
Yeah. Bright object.
Yeah. I'd like to see if I can go to 15 seconds. Yeah, I'm sure I could. Welcome to the Lagoon Nebula, folks. Summer is upon us. This is the first shot of the Lagoon Nebula this season, and the first time ever with this camera. Look at this little squiggle line, see it? That's incredible. That a lot of pressures in the nebula, stellar winds that are causing dust to move around. And then up here we have a rim. See, there's ionization going on here, and then around the corner you got dust, and the dust is mixing with ionized hydrogen, and the dust is denser back here, and the ionized hydrogen at the surface of this area right here is brighter. So it's a more dense area of ionized hydrogen, which makes sense because the stars inside are pushing out with their stellar radiation. They're pushing away gas and dust and shaping the nebula. The shapes of the nebula is directly related to the stellar nursery that's in here with this cluster and this O star that's doing a lot of the lighting up. If we want to see what's in there, we grab this handle and pull it way down, and that'll show us the interior better. See that? There's our hourglass right there. Actually, we've never seen it that detailed. Yeah, we've never seen it this detailed. This is actually pretty detailed.
Mm-hmm.
Look at this beautiful dark tendril right there. Very complicated dust tendril in there. I do remember the Cat's Paw Nebula. Don't think it's near the lagoon. See, there's a benefit to dragging this way down. Yes, you lose some of the data out here. See, you're all green. That's good. Very good. You lose some of the data, but you can see better inside the nebula. So we can pull this back and start to increase the brightness again. And let's go see where our dark, our black levels right here. Not bad. We'll save that.
I have to call it a night pretty quick here, Mark.
Okay. Yeah, it's actually 144. I mean, I see the summer sky and I'm like, let's look.
Oh yeah.
All right, let me stop it. Get out. Let me do one thing. I want to show you guys one last thing, which I promised to show you earlier. Okay, we're going to let this keep building up an image, and I'm going to try to show you an object that I mentioned earlier. And let's go to the window. While that's building up, let's go find our window. Yeah, window, don't worry. There it is. Okay. Alright, so what I'm going to show you here, guys, is something quite interesting. This is the AllSky Camera. Just prior to its failing, what's today? Wednesday? Yes. Yesterday it failed. Right after I discussed this on the air, and I can't understand how, but check it out. I'll just show you. It's a short video, but watch. Here's our AllSky. Watch right here. Watch what comes in. Wham! Do you see that? I know you didn't, obviously. But here it is in slow motion. Comes through, curves, and goes out. What was that? Right. You see that curve? Watch again. Now it comes in slow motion. And you see a curve right there. And then it fades out just like a satellite. So the question becomes, what was that?
Mothership.
Mothership. Wow, look at this. Oh my gosh, this is really pretty. Oh, this is going to be a stunning image. Look at this. Wow. We actually see this like almost three-dimensional, don't we? That's pretty.
Yeah.
Let me just do one color correction. And let's see how much more stuff is there if we do this real big. Yeah, look at that. Look at that. There's this neat reflection nebula here. This is on its way to the Chinese Dragon Nebula up there. This is on its way to the Trifid Nebula up there. That's really cool. Very pretty. Wow. Yes. The center of the galaxy has the most varied objects. Wow. Very cool. And we're going to drop this out of there now just for a minute. I know it looks better with the other, but we can accomplish the same thing by bringing this in now. But it's more controlled. Wow, that's cool. Very nice.
Yeah, that's a happy place right there.
Yeah. Alright, we're gonna save this just like this. 62 images stacked. Save exactly as seen. This will be fun to compare this with some of the others. Alright guys, we'll call it and say this is the end. This is the end. I want to thank you for coming out. This is a beautiful object to end on, the Lagoon Nebula. As we've saved these, they will be up on the server in just mere seconds. And then this photo will be available for you to download. So when we save it, and then save it exactly as seen, alright, this is what you're going to get. That's the object. That's the image right there that you can take and download. You could zoom in on it, you know, with your applications and check out all this amazing detail inside here. And there's a lot of it. Not bad. And we don't blow out the center, which is really kind of cool. All right. Well, I hope you guys enjoyed tonight. We saw 2 comets and some nebulae. Really, really a successful night. Hope you enjoyed yourselves all. One and all, I did. Adrian Thoman, thank you. Very nice to Better Than Fireworks. We're looking at the universal fireworks and nature's fireworks. Thank you for that comment. That's a wonderful comment. And we look forward to seeing you again. And I probably won't be broadcasting tomorrow night. But on Friday we probably will. I always try to take advantage of the fact that there's no moon.
Yep. New moon's on the 5th, actually. Friday.
All right, guys. Well, you have a good evening, and we will talk soon. All right? So let us know what you think in the comments. Also, make sure you give us a thumbs up. And we'd really love it if you guys could consider joining our Patreon, because we could use it. Patreon is excellent. It helps us do things like pay for the internet that we're using right now. Our Patreon subscribers pay for our internet. It's really something to help us out. So we can also get filters and stuff like that for the telescope. And the telescope I showed you out there earlier tonight that Marianne and Stan barged in on, which was hilarious. That's our new Benson telescope, and there's hopefully more to come, because I know people like Ray has been asking when are you going to have everything ready? And it's a matter of money. We can't just do everything. I wish we could. You know, if I was independently wealthy, we would have scopes all over the United States, all over the world. But we're not there yet. So we have to depend on folks helping us out. Anyway, I hope you guys have a good night, and look for the Lagoon Nebula up there. I'm going to go one more shot here, and it'll be 80 shots. All right, and then we'll save it exactly as seen. Nice. Okay. All right, folks. You have a good evening, and we will talk to you on the next time that we stream. Hopefully you guys will be around for that. So thanks, and we'll see you later. Bye-bye, everybody.
Good night.
Good night, all.